A very good afternoon, everyone. Thank you so much for having me. I'm Sheetanshu Tyagi from EMO Energy, and this is going to be a conversation around battery energy storage. So when we think of battery energy storage, most people imagine a situation like this. There are solar farms, there's a wind farm, a lot of windmills, solar panels, and containers of batteries basically doing backup. This is going to be one of the big futures we're going to have as a country. As a country that is extremely dependent on oil, GDP being a big concern for us when we're importing oil, battery energy storage is really going to be the future for this country, not just for backup, but also for energy generation. But what is this, and what do we really look at from a battery energy storage perspective? So this, we believe, is going to be the future of what a city would look like in the future. So you have a grid, you have some solar panels which are basically installed everywhere. So you have rooftop panels, you have an off-site solar installation, you have multiple fast chargers for different electric vehicles, you have slow chargers, and then you have battery energy storage right in the middle. All of this is basically going to be managed as an entire energy ecosystem where the battery works with the grid, it works with the solar, it basically becomes the entire buffer in the entire system. And this, we believe, is going to be the major focus for most companies from an energy perspective in the next 5 years. And this mainly happens to be 3 requirements that we're trying to meet with battery energy storage. Backup, which is basically to replace and kind of convert all your commercial DG sets to energy storage, which is clean and green. You have peak shaving, which is going to be an entirely new concept in India. So now we have open access grid. We're going to have energy trading concepts where we're going to buy at 2.5 rupees, try to sell at 5 rupees to certain people who don't have solar. And the entire model is going to be based around how batteries store at right times, buy energy at the right time, and basically sell it to certain entities which are basically looking for energy at a cheaper rate than the grid itself. And the last part, which is going to matter a lot for different companies on the grid side, is basically how do you ensure uninterrupted power no matter what happens. If there's a failure at the grid side, if there's a downtime, if there's any issue at all, how do you stabilize some of that power, make sure you have the right voltages reaching from the grid to all of the lines in the country, and how do you make sure this energy ecosystem that we're trying to develop is completely flawless. So we believe that the future is going to be very significant in terms of what the numbers are looking here. So today in this country, essentially, we did 300 megawatt hours last year. And the focus is going to be essentially going to be 10x in the next 3 or 4 years. Battery energy storage from both sides of this, from the grid side, from the private energy storage side, diesel genset replacement, all 3 combined are going to present an opportunity which is pretty much unparalleled to something we've seen in the energy world at least. The other part of this is that the government is launching a lot of support and a lot of subsidy to basically establish battery energy storage as a concept for everything, from grid side level kind of peak shaving all the way up to someone's house. And most of these systems, now that the future is moving a little bit, is going to be lithium ion. The lead acid systems and the diesel gensets that were basically existent, all of them are now going to shift to some kind of a lithium ion system. So we believe that the 3 problems though that are really stopping this, and the reason why this isn't already everywhere and that why you don't see this is very clear. So you have power requirements. Most times people will require power for very long duration of times. You'll need it for 4 hours, you'll need it for 8 hours. And you'll need it at a certain cost. There is already a mindset of what the right cost for this target market to grow is. And around 8,000 rupees or around $100 a kilowatt hour is the exact value where we feel that diesel starts shifting completely over to batteries, because the equivalent cost of buying, let's say, 250 kVA generator versus a 250 kVA battery setup is going to be the big game changer. And one issue with batteries in general, and we've obviously seen this, is battery replacement. Most batteries today have a kind of a life cycle around 5 years. Some are now starting to extend it to 8 years. But how do you warrant and how do you make sure you have 8 years life and you can actually make sure you can actually hit those numbers and hit warranty all across the megawatt hours of storage that is going to be set up? So we feel like there are very key problems to solve, and EMO as a company is basically solving these in a very specific way. So just to show you a little bit of a glimpse on what we feel the future of urban landscape will look like. So we basically call this EMO City. Actually, you could just go back. So we'll just play a quick video on this. This, we believe, is going to be what a future of the city looks like. So you have vehicles, you have dark stores, and you have different logistics hubs in which have fast chargers. They're charging multiple vehicles. You also have different larger size vehicles. So you'll have 3-wheelers, 4-wheelers, which will basically now operate with a backup system in the middle of it to become the buffer. And all of this combines as a system to basically create an ecosystem for energy. how do you basically make sure that the battery health for each of these systems is basically to the right side. And one thing that's going to be very big for us as a company is how do you take batteries out of vehicles and then put them in energy storage. As a company, we figured out very key technology parameters to now understand how do you take specific cells out of vehicles and then use them in energy storage. And I'll get into the crux of what we're doing special for that a little bit. Sorry, just go back, please. Just go back. So we have three forms of energy storage systems we're setting up today. We have for private markets, for smaller houses that we're doing 10 kVAs. We've started doing 100 kVA, which is basically for small commercial applications, and all the way up to 250 kVA to basically do multiple very large setups, which can then do for industrial and commercial applications all together. And all three of these are basically now in production and is something we're setting up very actively as we go. But the key around these is basically going to be how quickly we can scale, because we have the technology now. We've started already deploying a lot of 10 kVA systems. A lot of our systems are even white labeled for different companies who would like to kind of project their brand in certain environments. But the key focus for us is mobility charging, which is obviously becoming a very large part, and fast charging, which puts a very high load on the grid. How do you stabilize and back up that? So we've already tied up with at least 3 different charger companies to take their EV charging stations and provide battery backup for each charger. And that basically allows them 100% in uninterrupted power. So if you're doing a road trip, let's say from Mumbai to Pune, there might be 2 chargers on the way. But the biggest issue today for fast chargers is they only have 90% uptime. So 10% of the time they're just down due to power failure of some sort. And this is unacceptable in a world where we're running buses and trucks on this route, because now every single minute counts. So having a backup system for fast chargers, having a backup system for commercial industrial applications where diesel gensets is the norm, is going to be the key focus for EMO. And this basically translates to what we're doing in terms of technology. So we call a technology platform Zen, and there is very key specific patents that we filed globally now. So there's almost 16 patents we've already filed, and another 30 that we're going to file over the next year or so. And all of them basically solve for very specific problems that we basically see in energy storage. So for power, we have a very advanced cooling system which we've developed completely in-house. We have a strong 40% R&D team specifically working on these parts of it. We have a very detailed, what I call a machine learning model, which basically does life analysis and tries to predict and then improve what life you're going to get. And we also have a very sophisticated safety system, which basically uses a specialized fluid we've developed, a lot of pumps and heaters that we've developed ourselves, to make sure that in a country like India, where you're operating at 50 degrees, 55 degrees, to make sure you can always operate at 30, 35 degrees, which are safer temperatures for battery. And all of these combined are going to be the key here. As a country, we already know that lithium-ion fires have become a very big deal. And as a mentality, I feel like that has been a big blocker to us to completely scale 100%. The safety aspect of it is a big part, and that's why we focused a lot on this. And to quickly just show you a small, I'll just come to the video, but I'll just go to the video first. Can you go to the video, please? I have a small video just to show you how we're essentially doing some of the technology on this system itself. You play that? So this is essentially a battery module, and I'll keep stopping in the middle. So you have cells, and these cells are imported from a couple of different companies globally. But pretty much everything, how we bond those cells, how we electrically join them, how we're basically making a system out of them, the sophisticated electronics that we mounted on top, and finally our entire cooling system that basically maintains the right temperatures. All of these combined are going to be what really differentiate us from most companies, not just in India, but globally. Because we believe that right now, whatever technology we develop in India for some of this is very applicable in the global south, for example. So we feel like a lot of the Chinese tech, a lot of the American tech that's developed is very good for really large systems that they may be able to deploy, and that's working well. But some of the specific applications that we're targeting, like commercial, industrial, the power levels, the dust levels involved, the level of temperature we're operating at, those conditions now require specific tech. So India, Southeast Asia, Africa, LATAM, these regions are going to be very critical for us as a country to capture. Because if you take a 20 years back perspective, Japan is the country that was responsible for some of these. So all the DGs you ever see, all the two-wheelers, three-wheelers that are really prevalent in this company are all 80s, 90s Japanese tech. But in the electric world, China obviously has a huge edge on the cell side, but in the application system side, we feel like as a country, there are a lot of countries globally looking at us to basically be that replacement on an application level. And now with the US tariffs kicking in, us as a country can actually import a lot of the cells, be the actual exporter for that, and now be a clean source for exporting to some of these countries who are a little anti-China. So for us as a collaboration point, that's a large part. But one thing that also differentiates this whole system, and which we feel like other companies, even a country like China, is kind of missing out, is the level of software we've built out. So we have an entire management system which basically analyzes how the battery is getting used, which, like in a battery of, like, let's say thousands of cells that you have in a large megawatt hour storage system, which cell is off, predictive maintenance for those, and an entire machine learning model to now do financing for batteries. Because in the future, when you start financing batteries, health for batteries, who uses how much, which temperature they're being used in, which location they're in, ideally, all of them should have slightly different financing models. All of them should not be at the same percentage because they will never deliver the same health. Unlike ICE engines, where no matter where you put a diesel genset, it's going to run the same way, batteries are very, very dependent on the environment. So financing for that already is something we do a lot very heavily with mobility companies. So we have at least 6 NBFCs working with us to make this their back-end software from a PSU and a banking side to do battery financing, which is a very large problem today. So you'll only have, let's say, MG Windsor who is doing that, but the interest rates and the margins they're doing are extremely high. For us to get to a market where, let's say, financing batteries at 11-12% is unheard of. We are doing that at 18-20% today. And for us to get to that margin, understanding of health and quantization of finance of health is very critical. And that's something we do very well. And that's something we built over 3 years. And Rahul and I, who co-founded the company, have been doing for 15 years in our different companies. And this model is very critical to us. And one of the key things that also differentiates us as a company is basically how we're using cells. So like I mentioned, we are actually one of the only companies in this country who actually remove cells from vehicles and are repurposing them to now make entire energy storage units at scale. So a lot of people have tried this and a lot of people have attempted this in different ways. But the reality of what stops this from becoming big is the time involved. So these are Ola batteries that have come up from different Ola two-wheelers. We partner with JSW today, who is responsible for breaking up these into cells and then selling it to us. But the understanding of which cell to take, how much, which cell from where to which battery to take, how to combine them, how to make sure that the time of running these is as low as possible before you essentially get them is very unique to us. So our analysis software actually runs every single used cell that we buy in factory and is able to already predict how much health is lost and how much health is left in the battery. So this becomes a very key system for us as when we're scaling, because the differentiating factor for us now is going to be cost. As a company, we're able to get the entire cost down for this system at least 30-40% lower than what a Chinese, let's say, battery system is at today. So most companies will sell at somewhere around $140-$160 a kilowatt hour, and we're already under $100 per kilowatt hour, mainly because of how we've been able to understand life of cells and how we've been able to basically monetize some of that. So this is going to be the focus for us for the next few years. And just to maybe show you a little bit on our entire product portfolio. So we start from the smallest battery packs. We do two-wheeler battery systems. We've also started doing some four-wheeler battery systems for buses and for larger vehicles. And then we do the same batteries, whatever we're building in mobility, we apply that to energy storage. So as a company, this basically covers the entire spectrum of systems and basically allows us to scale in mobility and energy storage at the same time. That's me from, thank you so much everyone for listening. Any questions, please feel free.
Yeah. So some of the questions that
please.
See, so to reach the scale that they think you good, what is the kind of capital that is required?
Right.
Just to add to it, what will be a right to win? You mentioned a couple of things, the problems that you're trying to solve.
Correct.
But apart from that, I'm sure that when we are competing with China, you showed that there's some edge that we have in terms of how we are monitoring. But how difficult it is for them in knowing how technically sound they are.
Right.
For them also to copy what we are doing.
No, absolutely. So I'll answer this in two parts. So the competition to China is very real, right? Like especially for lithium ion and for EVs and in general, the clean storage space and clean energy in general. There is no other country in the world that is as far as that is China. And I'd like to say that at least in cell development and solar cell development and some of these technologies on the design level, at least 10 years ahead of us. And only because they're in hundreds of gigawatt hours on a cell level. And as a country total, we still have maybe maximum 1 gigawatt hour today. So the margin is huge. But the one big thing I'm seeing happening is China has developed certain applications really well. So they have, let's say, grid level storage they've done in China. They've done a lot of four-wheelers. They've done some very large vehicles. And we are not directly trying to compete with those applications. It is very critical we pick applications and pick sectors which are a little bit far away from them. So we started with two-wheelers. China has their own two-wheelers, but very light mobility type two-wheelers. The way we use them, like full trucks, is unheard of anywhere else except the global south. So if you see the top 5 OEMs also in this country, nobody buys from China. It's only because the ratings involved, the durability you have to hit, the warranty, the actual power, the energy ratings are so excessive, and then the cost you have to hit is very critical that you build a full system around this. So cells we will keep buying from China. I feel like as a country, cell manufacturing is going to be a bottleneck for the next 5 years till we start actually scaling that up. But once gigafactories kick in, I believe there will be a heavy amount of taxation on China to import cells then. And we are more than happy buying from Indian companies also. Our objective as a company is how do you use those cells and really extend life as much as possible. And that software, that understanding, that system is very critical to even India as a country, because utilizing assets to its absolute max is also a genuinely Indian thing. Like China is not doing that. China will just use it and then recycle it and then start again. We are extending 5 to 8 years, 8 to 12 years, and that is the key focus. So to sum it up, the approach and the focus of how we're building batteries is very unique, and that allows us multiple applications, which I feel China is not even focused on.
And what are the prerequisites for us to get qualified as a battery supplier to these two-wheeler OEMs?
Right.
Who are we competing with there?
Yeah, so before that, I think there was one question, funding also, which I forgot, the first part of it. So financing for this is obviously a big, large part of it, right? Because if I take a 250 kVA genset, and let's just talk about that, you can buy one for 22 to 25 lakhs. Now, a 250 kVA battery system, usually in the market today is at 35, 40 lakhs. So that itself is a problem. Like now your upfront cost is at least 20% more. And as a use case, you can use a DG forever. I can't use a battery for more than 2 to 4 hours. Even the best batteries in the world will work 4 or 5 hours. So what we've done is, by utilizing used cells, by actually bringing all that cost down, we are hitting that 25 to 28 lakh number for DG replacement. So you can take it that way. So 0.3 megawatt hour is around 25 lakhs. If you have to scale that up to 3 megawatt hour, 300 megawatt hour, it's just a multiple of that then. And to the next question, so the prerequisites for OEM. So getting into an OEM itself, I think, becomes a moat for us. Like once we're into a company like TVS or Hero MotoCorp or Escorts, it's been at least an 18-month process for us to get qualified at TVS. We've gone through their R&D team, then their senior R&D team, then their supply chain team, then their business team, then to their business heads. So it is a pretty rigorous process, and the good thing is, it's not something that you can keep redoing also with multiple parties. So there have been multiple startups in this game, there have been multiple Chinese companies, just multiple companies in this. The only reason we're standing out is because from the very start, everything we've done, everything we've focused on has a very heavy automotive focus to it. Like the entire process of design, the entire process of engineering. We've literally focused on trying to basically build the best processes for some of this, and that is why some of the OEM adoption has started for us. But I think the competition for us is not so much other battery companies, it's the OEMs building themselves. So for us to be at the right target price and to always be better than them in tech is the real moat. And everything else just follows. Like as long as we're better than them in terms of tech and can hit their target price with margin involved, it's a clear win.
And I think it's a known fact that BESS is going to be really, really large over the next 5-7 years, considering how we managed to reduce costs of storage. According to you, not in terms of gigawatts, but in absolute value, if you have to look 5-7 years out, how large would this sector be in terms of value?
So today we're already in somewhere around 12,000 crores, total combined value just for energy storage on the grid side. That by 2030, the estimate is should be 10x. That's the intent, because all the subsidies, all the programs combined are, there's a certain gigawatt hour number like I mentioned, so that's basically 10x of that number today.
Just one last question. Please. One of the audience members asked me, is the lithium source depleting? How do you secure the availability as a company?
Right. So lithium is an interesting material. Till the last 10 years, nobody cared about it. And the unfortunate part is there's actually a lot of lithium in the world. Nobody's really looked for it. If you hear, in the last 2 years, most people have heard of lithium reserves in India, lithium reserves in everywhere in the world. It's because now we're looking for it. In terms of actual cost of mining, that is still pretty high. But again, China has done an amazing job vertically integrating the entire supply chain. So they own all the mines in Congo, they own all the mines in LATAM, they own the refining process in China, they own the processing of those materials, they own the cell development process. Any country in the world who wants to get into lithium mines has to somewhere or the other go through China. So lithium as a source isn't really the problem. It's the end product from where it's coming that becomes the bottleneck. And there's obviously alternate chemistries that people are looking at. So there's sodium, that's a very big proposition that basically is going to be a very big competitor. But lithium prices, just from a raw material perspective, the end product perspective, have dropped so much in the last 2 years that most people have forgotten about sodium. And there is going to be a lot of work, then again, that's going to be mainly Chinese. But that technology itself, and for us to be able to utilize, will be big. Because sodium, we feel like a lot of the companies that are even working along with us in the Indian cell ecosystem, sodium will be a cell we can produce in India very well. Because it's one leap that we basically be able to skip, and then it's like how we skipped one layer of G, like in the telecom world, we'll be able to skip this lithium layer and go directly to sodium. It's an easier manufacturing process, all the raw materials are more locally available, and we can develop it into a system much better. But yeah, lithium is a problem today, and the intent is that reserves is not so much the issue. Reserves are coming up as we speak. Mining them and quickly actually making some value out of them is the big part.
Thank you so much.
Thank you.